On the previous video, or towards the end, I was sort of coming to the conclusion that probably the most likely fault was the RMS conversion chip, an AD1026, and that's on the back of the board here. Because I was typing in AD1026, I wasn't getting any hits at all, but when I realised that it was Analog Devices made the chip, and the 1026-301 or whatever it is was actually the HP part number, I soon found a cross-reference to what the chip was. And I also want to thank the people who, I think Stephen Bell, who added a comment on my previous video to tell me that that was the chip, and that was a great help. So once I knew what the pinout was, I started to look at what I was expecting to see on this chip when I put an AC signal into it, and that chip seemed to be working correctly, which was sort of good in one way because the replacement chip is about 20 quid. So I went back to this sort of thinking it was probably an problem with the attenuator. Now, if you remember here, I don't know if in the previous video I did this or not, but I've replaced this op-amp because these states weren't changing correctly, thinking it's a faulty op-amp or comparator, and I've changed that and made no difference at all. And the most troublesome problem was this point here. When pin 10, which is the inverting input, and pin 11 were at the threshold where the output should be low, it was always high, and whatever I did to these threshold points, that point remained high. So I was thinking, well, I've changed the chip, I'll try another chip in it, tried another chip in it, same thing, that point was always high, whatever those inputs of this comparator were. So the next thing I tried, and I spoke to a chap at work who gave me a few sort of ideas. He said, well, check to see how much current these can sink on the output, make sure this pull-up resistor hasn't gone short, which is extremely unlikely. I mean, pull-up resistors don't tend to go short anymore anyway. But they all sunk the same amount of current, so they were all similar, and didn't get anywhere with that. The voltage on the other side of the diode was 0 volts, so it wasn't being pulled up with a leaky diode or anything like that. So I was thinking, what the hell's going on? And last night I was sort of pulling my hair out, thinking, you know, can't even diagnose a bloody comparator circuit. Anyway, I thought I'd chuck it a bit in the car and take it to work and get this chap who's sort of worked in this stuff for all his life and see if he had an idea. And he did exactly the same thing. We set it up in the workshop and he plugged it in, and I said, well, look, you know, pin 10's high, pin 11's low, why is pin 13 still high? And he said, that's a bit strange. He said, I've never seen that before. So we tried another chip in it. I said, well, you're wasting your time, we've tried this. But he put another chip in it, same thing. But then what he did is he put a scope on pin 14 and then put a scope on pin 10 on the second channel. And at that point, that level dropped low. And when he removed pin 10, it jumped up high again. So straight away we said to both of us that, sorry, it wasn't pin 10, it was pin 11. We put it on pin 11, so it's pin 11 and pin 13. Straight away it suggested that the input of this op-amp was just floating in midair. And that's, I don't know if I said this in the previous video, I was suspicious of this shift register here, which is a 4094. I didn't think it was actually controlling all these op-amps correctly. So I'd already ordered one of those at the beginning of the week. I think I ordered it on Sunday and it turned up today. And he said, well, I must admit, it does look like the shift register's not, you know, burnt out, open circuit. It's almost like there's no connection. And when we tried touching it actually on the pins here, so rather than going on pin 11, we touched the corresponding pin on pin 11 on the 4094, had the same problem. So anyway, to cut a long story short, the chip turned up today. I cut the chip out and put a new chip in, started it up. Same thing, error message. But when I looked at these points here, they were clearly working. They were switching exactly how you'd expect them to do. So that chip was faulty. So at that point, I was only in work for half a day, so I needed to sort of spent 10 minutes in tea break just to quickly check something. I checked to see if the meter would respond to an AC signal, which it did, and it was reading correctly on all the ranges. So that was a massive leap forward. The only problem is the meter is still showing this error message on startup. Now that could be a number of reasons why that is. I have performed a calibration on this now. If you remember, one of the calibrations was to try and set the zero offset with the trimming capacitor. That was on the previous video, and I'll just try and demonstrate that now. So if we go shifted, and then we go auto 0 and scroll down to diagnostics, press 8 and press enter, what we should be seeing here is a 0. See, it's passed. Now before, you out of shot, sorry. Now before that was oh, it's failed now. That's interesting. We go back to pass again. So it's on the cusp. All right, the unit hasn't warmed up properly, but that's a trimming capacitor where you have to balance out this zero offset, and it's right on the verge now. And I'm just going to quickly tweak that a bit now, just to bring it in slightly. But this meter has just come out of the car, and it's not warm, so it's not ideal environment at the moment. I'm just going to trim it so I can get it to stay passed. So you can see that's clearly passing fine now, and before I couldn't adjust that. Whatever I did, it wasn't making any difference at all. So that's clearly fixed one of the problems, but as I say, I've still got this problem now where it's failing on the self-test. Now at the moment you've got to bear in mind all the screens are off and things, so it's probably picking up a lot of RFI from the lights and God knows what, but it is adjustable and I can get it to pass, so that's a good state. So what I'm going to do is I'm just going to quit out of that for a second. So it's a reset command, holding that down, that resets the unit. I'm going to feed in a couple of signals into the meter just to see what it does. So this is presently a 10 kilohertz signal at 1 volt, and just see what we get on AC volts. So press AC, 993 millivolts. Okay, quite pleased with that. So let's try a lower frequency, because the error code it's still coming up with is suggesting that the amplifier or the AC board is not flat. Let me just zoom out a bit so you can see a little bit more what's going on. So what I'm going to do is I'm going to change the frequency to 1 kilohertz and see if we get a shift in the level. Very marginal, very little. So we'll try 100 kilohertz. So to me that looks flat, but clearly this meter thinks, and I'll demonstrate this now. What I'll do is I'll run a auto calibration on the AC section only, and to do that you press shifted, number of power line cycles, scroll down to ignore that's the wrong thing, so you go backspace. So that's actually restart it. That procedure I've just showed you was to show you the in-depth error message. So it's simple as this: you press auto cal, you press 3 for AC, and you press enter, and it's running the calibration routine. Well, it will fail this simply because there's still something wrong with it. And the next question comes up: what is the problem? Now, I posted a couple of messages on the EEV blog forum, and one chap's been very helpful, and obviously got his head screwed on and knows what he's talking about. And I've asked a question about one of the chips in here that I'm not entirely sure what it's doing. We'll finish calibration any second now. Well, guess what? It didn't fail. It didn't fail that time. Right. Okay. So it should have come up with an error message, but it looks like it's passed the calibration. So I'll do a self test. This is a full self test on the unit. Let's see what this does. So before I jump to the conclusion that there's something else wrong with it, let's just see if it test failed. Okay, so we have still got an error message. We've got hardware error. Okay, so we know there is still a problem. Now to see what this hardware error is, you press shifted, number of power line cycles, scroll down to auxiliary error and press enter, and it will be 256, which is AC response flatness error or out of tolerance. Okay, good. I thought it was going to pass. Well, I mean, it'd be nice if it would have passed, but I thought it was going to sort of make a liar out of me, sort of thing. So the next point is we've changed this chip up here, and this is the shift register, and here the data line's feeding some other shift registers. There's two others here. One of them controls the relays for various things, and that seems to be working fine. All these relays seem to be shifting state. But there's another shift register down the bottom here that comes up to this analog to digital converter. And what this is doing, apparently, I can't see how it works, but it's I can see it was some sort of capacitive effect, because if you look at the output of this chip, it feeds through here, and it's not actually connected to the gate of this transistor. It's actually connecting to this. It's like a screen round it. If you can see, the connections actually going to the screen, and apparently what that's doing is altering the capacitance of the circuit, which is sort of what I thought it was doing, but I couldn't see how it was doing it, to compensate for sort of like a high frequency roll off and things. So this is part of the calibration routine. So the next question is, it looks to me like this chip isn't being controlled, and it could be possibly this shift register is also blown up as well, because they were, if this one failed, I don't know what the hell happened, but it's possible it's taken that one out again. So I'm going to set up the scope and try and see if we've got any shifts in the shift register. But one of the chaps on the EV forums was saying that it was only expecting a couple of these to shift in a normal sort of like calibration routine. So not entirely sure if that's what it is, but we could set some sort of voltages into it and just see what it does. Run the calibration routine and see if any of these points are changing. So I think that will be my next port of call. Right, the plan is to look at the outputs of this shift register that feed to this digital analog converter and see if we get any state changes when we do various things. I just want to ascertain that this shift register is actually putting some outputs into this DAC, and that would hopefully give me an idea if there is actually, if it's working or not. So I'm looking at U316, and that's going to look at the various lines. I'm going to look at 4, 5, 6 and 7 first. So I'm going to go to 4, and hopefully the scope will single shot and grab the frame every time there's a state change. So let's go to AC volts. Okay, we've got something straight away, it's good. So there's obviously something happening there. And the shift ranges, yeah, we're getting a trigger there. Okay, that reason why that's roll-off slope on the scope is because I'm AC coupled. If we go to DC coupling, slow it down a bit more, 20 milliseconds. Okay, so we're getting a shift change on pin 4. So it's obviously this shift register is obviously doing something. Going to 5. Our trigger point, let's bring our trigger point down a bit in voltage wise. So our trigger point is now at 600 millivolts and we're at 2 volts per division, so it's sort of a quarter way up the trace. Okay, there's nothing on 5 by the looks of it, so let's go to the next one. So it should be 6. Very difficult to see, but I don't know if you can see these LEDs here. It actually is triggering. It's not easy to see the update on the screen. I'm trying to make it a bit easier to see. Let me try this in auto mode. I'm trying to make it as I can see that it is actually doing something, but I'm trying to make it so you can actually see as well. Roll mode because we're slow time based. Let's try an auto. Acquire. Don't see anything now. Okay, that's better, isn't it? So you can see. Let's do this again then. Sorry, it's going to start from the beginning so we're clear on what we're getting. Boat race is in the way of the camera at the moment. So let's have a look. 1, 2, 3, 4. Okay, Clearly got state change on 4. Look at the wrong bloody chip. 1, 2, 3, 4. Sorry, start again. Okay, there's a shift change there on 4. And 5. Okay, it's the same as last time. No change on 5. 6. Yeah, that's working. Try 7. No change on 7. So what else are the output? 7, that's 11, 12, 13 and 14. So there's a 16, 15, there's 14. Chip. Well, that level is changing, but it's not doing a lot. It did change briefly. Okay, I'm not so sure about 14's doing anything. Let's go 13. 13's not doing anything. 12 ain't doing anything either. So these will be pin 11. Okay. So this is very similar to what the other chip was doing. There's not much of a change in states, and some of the outputs seem to be sort of like stuck. Now, I don't know if that's right. I don't know if that's wrong. I've tried various things to try and get these states to change. The other thing you can do is do an auto cal on it again, just to see if it anything shifts about them. But it seems to be that these points are stuck in the wrong state. So I have another 4096, 4094, not 4094 chip. So I think I'll do is replace this second chip as well, that I'm suspicious of, just to prove the point. The chips are cheap, cheapest chips actually, and try that and come back and see if that fixes it. Okay, I changed the shift register, and that made no difference at all. I was starting to think, well, I don't really know where to go next. I could have changed the last shift register, but I don't think that was going to be the problem, because it was controlling the relays correctly. So I sort of went in for dinner and had a sort of mulling it over whilst I was eating. And I thought, well, I wonder if it's because it's picking up noise in the workshop, because I haven't got any of the screens on. And of course, when we were running the calibration with the capacitor, you could see that every now and then it would flag up a fail, and then it would say pass again. And likewise, if I was feeding a low, very low signal in, the signal was jumping all over the place, irrelevant of how many power line cycles I was putting into it. So I thought, well, maybe it's just picking up noise. So I've just come into the workshop again after dinner, and this is what happens when you do a self-test now. Self-test okay. So that's the first time we've ever had that. That's obviously cleared the problem with possibly noise being picked up in the AC board. The final and ultimate test is to do an auto calibration on it, so we're going to do that now. Auto calibration. I'm not going to enter the digit to actually make it calibrate just the AC level. I'm going to calibrate the whole thing. This usually takes about a minute, so the suspense you can share as well. We come to the end of the calibration any minute now. Okay, it's diverted back to the AC range, and we're just going to call up any error messages by pressing shifted error. no error messages. So that's fixed. The nice meter 3457 should be a great meter. The problem is with all these workshops is finding room to put it somewhere. I'd like to use this meter. Unfortunately, it takes up a sort of like a rack mount size, but I'm sure I can cram it in somewhere. We'll do another video at a later stage to show what it can do. But it's certainly seems to be working well. It's got a lot of facilities on it. It's got a lot of sort of like not data logging so much as, but it can sample multiple signals in a period, so I can set it to do 100 acquisitions and give me an average, a minimum, and a maximum. So it's quite a useful multimeter. I suppose the modern meters can all do that now, but I just think that the Hewlett-Packard stuff will probably be a bit better quality and more reliable, hopefully, in the long term. When the Chinese multimeters, capacitors all need replacing, this thing will still be plodding along. Anyway, I hope that was a reasonably interesting video. I've got another Roberts radio to repair, and I think I've got some other bits and pieces that need looking at that people have bought in. But in the meantime, thanks for watching, and there will be more.